Saxon Algebra 1/2, Lesson 76. Multiplication with scientific notation. Multiplication with scientific notation. We're getting into now what scientific notation is really good for. When we have really, really big numbers or really, really small numbers and we want to do operations with them, addition, subtraction are not really the operations we're going to be doing that often. We're more likely to be multiplying or dividing. So we're getting into how to use these codes to do operations on the numbers. So I think you will like it. We're going to multiply, as you can guess, and we've got numbers already in scientific notation format. John, instead of just having the two parentheses right up against each other, he actually squeezed an X in there, like a regular multiplication sign. I skipped it, but imagine there's an X in there. Okay, to multiply, numbers in scientific notation. Notice these are already in the proper format, right? There's just one number and the decimal place would be right there. And then we have a power of 10 raised to an exponent. So the first thing we do is we multiply the one-digit numbers. In this case, it would be 4 times 2, and that's 8. Then the second thing we do is we add the exponents on the tens. 5 plus minus 2. Here, we'll do it the way we're learning in other lessons just to make it super annoyingly precise. This becomes plus 5 minus 2 is 3. And then we format our answer by taking this number, 8 times 10 to the third. Okay, so we calculate the answer in 2 steps. First, we grab those two numbers and multiply them. Then we take the two exponents and add them. And then we use those two answers to build the product of our multiplication problem. Yeah? Yeah. Okay, stay right there. I have to grab more paper. Okay. This is 76 continued. We're going to do the second example. 10 to the 8th, and here I'll put the X in this time, times 3 times 10 to the third. We multiply the two numbers. 3 times 3 equals 9. We add the two exponents, x plus 3 equals 11, and then we format those two numbers as our answer. 9 times 10 to the 11th is our final answer. Okay, and we have one more, and this one's got the curveball. Okay, here we go. 4 times 10 to the minus 6. Don't let that negative exponent scare you. It's just a negative number to add, no big deal. And this, 6.2 times 10 to the 4th is our second number. Okay, so we multiply the numbers. Now this one's got a decimal. That doesn't necessarily make it harder. We just have to be a little more careful in our multiplication. 6.2 times 4, that's 8. That's 24, and we have one digit behind a decimal place. So our answer here is 24.8. And then we add our x 6 plus 4. That would equal minus 2. So we say, okay, it's 24.8 times 10 to the minus 2. We did everything right, but there's a wrinkle in this one. This is the curveball John threw us. This number, you'll notice, is no longer in proper scientific notation because there are 2 digits to the left of the decimal place. We don't want it like that. We want it here. So we're going to fix this number by rewriting it as 2.48 times 10. Now we know it's just one jump. Is it a positive one or a negative one? The question we ask ourselves is that, does this number get bigger when we convert it back, or does it get smaller? We want it to get bigger. We want it to be 24, so that means this stays positive. Okay, so this is correct. Now we bring down this other part, times 10 to the minus 2, and we put those two together again. So our final answer is 2.48 times 10 to the 1 minus 2 would be minus 1. That is our proper and correct final answer. So the moral of the story is we have to, if our answer gets bigger than just one digit, we have to fix it by rewriting it in scientific notation again and then combining it with the rest of our answer. All right, those are a nice little challenge for you. Good luck with them, sir. And hopefully I will see you in person next Tuesday. Thanks, Caleb.